Create a new project.
Create a new 3D Atomistic document by right-clicking on the project. Determine repetitive unit. I'm taking graphene unit cell for demonstration purpose. Graphene has 2 carbon atoms in a unit cell like the picture above. Select the Sketch Atom tool from the top bar tools and select the element from drop-down menu. You can select from periodic table option also. Start modeling with the pen, using left mouse button. Use single click to add an atom, and double click to finish the modeling. One tip here, for larger unit cells, add one atom first. Then, change the display style by right-clicking on the black window and selecting ball and stick option from the menu. Create another 3D Atomistic document. We have to get an approx idea about the lattice parameters A, B, C, and alpha, beta, gamma. Don't freak out, we don't have to give the exact values. At the time of geometry optimization, Materials Studio itself will adjust the values. For graphene, A is equal to B is equal to nearly 2 of single C bond distance, and C is greater than 15 angstrom. Alpha and beta is equal to 90 degree, and gamma is nearly 60 degree. For 2D structure, there are only interactions in 2 directions, and in other direction, there is no interaction between 2 adjacent layers. It is assumed that, if the adjacent layer distance is greater than 15 angstrom, then there is no interaction between those 2 layers. This no interaction region is called vacuum layer. For 1D structure, there will be 2 vacuum layers in 2 directions. It is better to use 20 angstrom to avoid any kind of confusions. Keep in mind, you can have to increase the vacuum layer distance if there is too much buckling in your structure. You can use measure tools, like distance, angle, etc. from top bar, to understand the approximate values of lattice parameters. Let's create the 2D sheet now, using Build option from top bar, after going to the newly created 3D Atomistic document. After clicking Build, click on the Crystals option, and then finally, Build Crystal option. Go to Lattice Parameters section under Build Crystal tab, and enter the lattice parameters, and finally click Apply. Copy the modeled unit cell element and paste into the built crystal lattice. Align the unit cell element in one plane, using the movement tool from top bar. Use the 3D viewer selection mode tool from top bar to select the element. Change distance and angles to perfectly adjust the modeled element in one plane of the crystal lattice. If you need to modify the lattice parameters, follow the steps. Step 1. Select a pasted model element and cut. Step 2. Modify the crystal lattice using Rebuild Crystal option under Build menu from top bar. Step 3. Paste the modeled element in the new lattice. To select the element, as well as the lattice, press A, holding Ctrl key. Increase number of unit cells, that is, value of A, B, and C, using Display Style option under Lattice section. Right-click on the black window to open the Lattice section. As the bond distance between two carbon atoms became very less than normal CC single bond, we had to modify the lattice parameter again. Now, we have to connect atoms between two different unit cells using the sketch atom tool. We have to assign the crystallographic symmetry corresponding to the material using Find Symmetry tool from top bar. Different tolerance can give different crystallographic symmetry depending on your material. So, you should have prior knowledge of crystallographic symmetry and point group of your material. Here, we couldn't impose the symmetry as some atoms came very close to each other. Most of the cases, you will see a place of one atom, more than one atoms are there. Simply delete the extra atoms, and keep only one atom, and finally fix the bond connectivity. Try imposing the symmetry again when you are done with fixing the issue. Now, you can change the unit cell numbers of your choice. Congratulations, your graphene 2D sheet is now ready.